Hi students, we know that the area from A till B of f of x dx is the area between f of x dx axes. What is the difference between if I put absolute value, if I don't put absolute value? If I put absolute value, for example, if the area is down, it's always be positive. However, if you have, for example, here like intersection, if I don't put absolute value, if I do the area from A till B, as if I'm doing, because here the curve is above than below, as if doing the area above minus the area below, because here the area will be negative. However, if I put absolute value, I'm taking each one alone. Here it will be the question to find the area. I do from A till C alone in absolute value, from C till B alone in absolute value. So I have the sum of two positive areas. However, here, if I don't put absolute value, it will be the part above minus the part below. If you have area between two curves, here f of x minus g of x, this is positive certainly, but if you have g of x minus f of x, because g of x is below minus f of x, it will be negative. If I want to find the integral from a till b of this red one minus the blue one, since I have a part the red is below and a part red above, if I don't put absolute value, it will be minus a1, because here f minus g, f is below, minus a1 negative plus a2. And if I put absolute value, so it will be A1 plus A2, each one in absolute value, so the sum of two areas. Before we start by the area calculation, I need to tell you, if the function is even and you want to find the area from minus a till a, it's the same as, for example, finding 2 from 0 till a. No need to find from minus a till a, because the function is even. And to recall, what is an even function? If you replace x by minus x, nothing will change. And if you want to, we're talking without absolute value here, okay, in these two examples. If it's odd, symmetric with respect to x-axis, the origin, if we replace x by minus x and y by minus 1, nothing will change. So the area from minus a till a, these two areas are equal, but one negative, one positive, it will be 0. Let us take that example. As you can see, that example is even. So instead of finding from minus 4 till 4, I can say from 0 till 4, but double. 0 till 4 double, because here x cube is odd, sine x, we know sine minus x is minus, sine x is odd, 2x is odd. So from minus 3 till 3, no need to do any calculation, it is 0. So now it's time to start by integrating with respect to x. In the first part of this video, we're going to talk about integration with respect to x. In another video, integration with respect to y. Find the area of the following figure. I gave you two figures here. The first one, I want this area. So as you can see here, the area is bounded between f of x, the x-axis, and from 0 till 2. So I say area is from 0 till 2, above minus below. But since this is the x-axis and the equation of the x-axis is y equal to 0, so no need to say 0. I do that directly. Instead of saying x squared plus 1 minus 0, I can say directly x squared plus 1. So it's x cubed over 3 plus x if I solve the integral from 0 till 2, and this area will be 4.67. However, you know that this function is even. Suppose I said that I want the area from minus 2 till 2. As you can see, because it's even, the same measure here is the same as measure here, so I can do double of the one above. Here, I want the area between f of x, this area. You have here f of x, and here you have the x-axis. So as you can see, this curve will cut the x-axis in a point. So I cannot do it directly because I'm talking about area. If I'm talking about the integral, okay, no need, so I do it directly. They subtract each other. Because I want area, I must do first of all, as you can see here, the green is below. So I need to be positive, or either you put absolute value for each one and you don't care about the position. But because I didn't put absolute value, I can say minus from 0 till 1 of the green minus 0. Because if I say green minus the one above 0, the answer must be negative because the green is below. So not to be negative, either I put absolute value or I put negative before. Then I do from 1 till 2. The green now is above, so no problem. So it will be f of x minus 0. So if I solve that integral, you can check from 1 till 0 plus that one. Here, as you can see, you get negative because the green is below the red one, this one, the x-axis. So you can get 2 units square. So always area, you need to check if we have intersection. If you have intersection between, you split the integral into parts. Another example here, I want that area, so no intersection. So directly I said above minus below. So f of x minus g of x. If I say g of x minus f of x, it will be negative. However, above, if you don't want, as I told you, you can put absolute value. So if it's negative, it will be positive. So no need to take into consideration this sense f of x minus g or g minus f. So I wanted, as you can see, from -1 till 2 above, which is f of x minus g of x. As you can see, f of x is x squared plus x plus 1 minus g of x is x. So if you do subtraction, you're going to get x squared minus plus 1. If you do the integral here, you're going to get x cubed over 3, as you all know, plus x. And if you do it from -1 till 2, you replace first of all by 2, then you replace by -1, you're going to get 6. Here I want the area between these two curves. Here, as you can see, I have intersection. There is a common point here. So in the first part, this is f of x, this one. F of x is above till here. Then f of x will be below from 1 till 2. So we start first of all from -1 till 1. From -1 till 1, I do it because I want the area. So it will be above, this is above, f of x minus g of x. Then from 1 till 2, it will be g, this is g, this one, minus what? Because above minus below. If you do f of x minus g of x, the difference between the two you have here, f of x, as you can see, it's minus x squared minus 2x, and here it is x squared minus 4. So if you do, you're going to get that one. Okay, so if you do it in the first one, you keep it as it is from -1 till 1, because the curve f is above. Then you switch in the opposite sign, 2x squared plus 2x minus 4, because we have now g is bigger than f. G of x minus f of x, just the opposite from 1 till 2. And if you do calculation, you're going to get to positive sign. If you don't want to go into f minus g or g minus f, you can put here absolute value plus absolute value. You can write the same here and the same here. Here you're going to get a negative number. In that case, if you write this one as it is, you put absolute value, it will be minus 3.67. In absolute value 3.67, and you get the answer. More example, here I want the area. You have 3 curves. As you can see, this is the first curve f. Here you have y equal to 4. This is y equal to 4. I have 4 boundaries, and you have 1 g of x here. As you can see, I have 3 boundaries. I must take 2 by 2. I start from 0 till 2. As you can see, if you split it together here, you have this red one minus this blue one. So it will be from 0 till 2, the red, which is f of x, minus this one, the blue one, which is g of x. Then from 2 till 4, you have this part here from 2 till 4. You have this one above, which is y equal to 4, minus the one below g of x. So I must split it into area 1 and area 2, because I have 3 boundaries. I cannot do it before as 1, because this part here is the red one minus the blue one, and here from 0 till 2, which is f minus g, and here it's 4 minus g of x from 2 till 4. So if you do it, f of x is 2x, g of x 0.25 x squared, and here this curve is 4. So if you do the calculation, you can check by yourself. So you're going to get 6.67. In this problem here, now picture are not given, we need to draw. Find the area enclosed between, we don't have that picture yet, so we're going to graph it by ourselves between these two. So first of all, I find the intersection between the two. So if you equate it, you're going to get -1 or 2. If you replace here by -1 or here, you're going to get the first point. If you replace by 2 here or here, you're going to get that point. So particular points, first of all, this is a parabola. You have -1, 1. This is the first point. You have 2, -2, the intersection. Because it's a parabola, I need a third point. Let me pick 0, which is between -1 and 2. If you replace by 0, you have 2. It's a parabolic curve. It had that shape. And this is a line. So line passing by these 2 points. So I want the area between. So I have the green above the black curve. So it will be from -1 till 2. The green, which is 2 minus x squared, minus the one below, which is minus x, it will be plus x. You can solve the integral. You can check it by yourself. You're going to get 4.5. Another example here. I want the area enclosed between the first quadrant, bounded between y equal root x, the x-axis, and above by y equal x minus 2. I have here, as you can see, I have 3. Root x, x-axis, y equal x minus. So I'm going to start by root x equal x minus 2. So you square both sides. You have this equation. You have two values. But don't forget, this is important. Don't do the mistake. If x is 1, if you replace here by 1, you're going to get 1 equal minus 1. Square root can never be negative, so this is rejected. So only I have one point of intersection, which is 4. If you replace here 4 by 4, so 2 equal to 2, correct. So this is the point of intersection. Now I want to graph the first one, root x. You can take 0, 0. You can take 1, 1, and the point of intersection. The other one is a line. You can pick, for example, if 0, it's minus 2. Here, this is the line, and you have that point. So what I want the area enclosed between this green one, the blue one, and the x-axis. So I want this region up. As you can see, how many boundaries I have? I have 3. 1, 2, 3. So I split it 2 by 2. First of all, from 0 till 2, the green, which is root x minus the x-axis, which is the equation, has 0, equal to 0. Then from 2 till 4, the green minus the black line. Okay? So if you solve it, you can solve the integral. This is a calculation. You can check your answer. So I have 3 boundaries here. This is the first one, the green minus the 0, the x-axis. Here, the green minus x minus 2. The last example about that, find the area bounded between two curves. Here I have. So I equate to see the intersection. I have 2 points of intersection. You can check by yourself. This is the first point, minus 1. You have the first point, minus 1, 1. And this is the second one, 2, 4. For graphing the parabola, you can pick 0, 0. So you have this curve. And the third one, it's a line. But I want it from minus 2. So you need to take another point. If you take minus 2 in the parabola, you're going to get what? 4. So I have that point. So I want the area bounded between minus 2 till 2, from minus 2 till 2, and between the green one and the blue one. So what will be the region? It will be that region. I have a part here, and I have a part here. But since the two curves intersection, so I must split. I must take, for example, from minus 2 till minus 1, the green minus the black. I mean the green, which is x squared minus x plus 2. It will be minus x minus 2. Then from minus 1 till 2, now the line is above. So I put the line, which is x plus 2, minus the green one, which is minus x squared. I can solve the two integrals. I can find the answer. So this is in the first part in this video. It is finding the area. Either I'm going to give you the picture, or you graph it by yourself. Either you have area between two curves, or you may have 3 curves, as we did up here. So you must split, and if you have intersection, for example, you must take into consideration the intersection and do each one alone. In this case, you split the integral. In the second video, we're going to talk about integrating area with respect to not the x-axis, with respect to y-axis. See you in the second video.